This conference will now be recorded.
Okay, so good morning all and welcome back to the session. This is Big Data Masters program. In the previous session, friends, what we have discussed how to refer a particular column. And we have gone through with multiple ways in PySpark how to refer a particular column. Like what is happening in the normal world. See, we are having certain data in terms of files. What we are going to do, we import it. We import that particular data. And then what we are going to do, we are going to do the processing onto top of that particular data. You can think in this particular way. We are having a particular CSV file that is having certain counters, and those particular counters are utilized in order to create the KPI. So what we need to do, we just need to apply the formula onto top of those particular counters, and then the KPI will be prepared, and that come inside the processing part. But for that, what we need to do, we just need to select certain columns, like these are the columns which are required for say throughput, which are required for say certain analytics, okay, which are required for DCR calculation. So you just need to select the counters, and counters are available in terms of columns. So how to refer a particular column, that was the stuff what we have covered in our previous session. So these are certain ways, like almost we have gone through with 6 methods, and with the help of these particular methods we will be able to refer a particular column, and then we can do the aggregation and processing on to top of those particular columns. Then we moved with data visualization part, like how to do the visualization. What is happening in the big data world? We are having huge amount of data, and once we are going to process it, then the outcome will be very small. So if the outcome is small, then why we need to leverage PySpark? Why we need to leverage the entire cluster? Just do the processing onto the single node only. Okay. At that moment, what we are going to, what we can do, we can convert the PySpark data frame to Pandas data frame and apply the visualization onto top of that. So this particular stuff we have seen, and we have gone through with bar plot and pie chart, histogram, box plot. So these particular things we have seen in our previous session. So let me delete this. This is with respect to previous one, and let me start with the day. So so far what we have seen, if we talk about the optimization, there are two types of optimization in PySpark. Optimization in PySpark. So one is say resource level optimization, and second one is application level optimization. So once we are talking about resources, the first thing, the first question, what will come in our mind are the given resource enough or not? The given resources
Sir, your
enough.
window is not shared, sir.
Oh, my mistake, guys, my mistake. Let me share it. Let me share it. My mistake, friends. Thanks. Thanks, Naresh. I forgot to share. So, hope it's visible. Is it visible?
Yes, sir. Yes, sir. Now visible. It's.
Okay. So, we were talking about the previous session, what we have covered in our previous session. Now, today we are discussing about the optimization in PySpark. And These are two types of optimization. First is resource level, and second one is application level optimization. So the first thing what will come in our mind, are the given resources enough for this particular application? Okay, so that is the first thing. Over here we are talking about, say, the core, okay, memory, okay, num executor. Okay, these are the things what we keep in our mind once we are talking about resource level optimization. Say the application is not working with two core, we are getting a lot of latency, huge latency is there. Then what we can do, we can increase the core, we can increase the number executor, we can increase the memory as well. Okay, so different things are there, but these are centered towards the hardware only. Yeah. So that is resource level optimization. By increasing these particular resources, we will be able to optimize our job, and the latency can be reduced further. That is the first thing. Second one, application level optimization. With respect to application level optimization, we are having focus towards the code. Over here we are going to optimize the code, optimize the code in terms of, say, we can have compression, we can have partition by, we can have bucketization, okay, bucket by, okay, we can have broadcasting joins, then compression, partition by, then file formats, we can choose uh, the parquet or column oriented file format in order to boost the performance. And what else we can do, shared variable, we can say accumulator. Then what we can have, repartition and coalesce, and then reduce by key instead
Group by also, sir. Group by.
of group by key. Okay, so these are nothing but certain optimization techniques, and what we use to apply in order to boost the performance. But apart from these particular uh, clause or techniques, there are certain other techniques or other clause what we can do, or certain configuration basically what we can apply in order to boost the performance. So the first one, we are going to discuss about those particular techniques. In today's session, we are going to discuss the rest of the techniques what we can apply onto top of our data or top of our application, so that the application will be more performant. So first one is AQE. Okay, AQE, that is adaptive query execution. AQE, adaptive query execution. So with respect to the adaptive query execution, this particular property came after, or in Spark 3.0. Okay, in Spark version 3, this particular property has been, you can say, evolved. And what is the meaning of this particular property? Basically, what was happening uh, inside the Spark, if like AQ is not available, then what is happening? Like for an example, we are having a particular application, and Spark is going to go through with the complete execution and complete, you can say, application. And after going through with the complete application, then it is going to prepare a plan, and based upon that particular based upon the it is going to prepare, you can recall the catalyst optimizer, huh? So what is happening inside the catalyst optimizer? We are having a particular application or query. Then that particular query, let me show you so that it will be more clear, huh? Let me show you. Catalyst optimizer, huh? Image, huh? We are just going through with the image. Okay, so just have a look onto this. It is YouTube link, huh? Catalyst optimizer, huh? This is Databricks, huh? Okay, so just have a look onto this particular catalyst optimizer, huh? We are having a SQL query or data frame, and that can have certain syntax related errors. So it is given to unresolved logical path over syntax or keywords related error will be checked. Then it is going to map all of these particular queries, and from the catalog a reference is made, and then it is going to analyze, and the logical unresolved logical plan is converted into the logical plan. Then on to top of this particular logical plan, which is free from error, which was there earlier, so certain optimization has been applied, and we got optimized logical plan, huh? Now, on to this particular optimized logical plan, Spark is going to check, say, this particular task, what are the different ways in which I can do the execution of this particular task. So, based upon this particular optimized plan, different physical plans are generated. Physical plans that will be actually mapping onto the hardware. So different plans are there, but all of those particular plans will be having the different cost. Cost in terms of latency. Say one application is going to uh, perform the execution in 1 minute, another is in 50 second, another the third one in say 40 second. So it is these particular physical plans which was generated in this particular step will be passed through the cost model, and the plan which is having least cost will be selected, and then it will be converted into RTD. So just let me try to correlate it with AQE. So before AQE, what was happening in the starting only, it is going to prepare the plan based upon the execution, based upon the flow of that particular application. AQ is going to uh, without AQ, the Spark is going to prepare a plan. But say the execution is going on and there are certain changes. Some resources are down, there is certain ambiguity inside the cluster, certain machines are not performing good. So the job will take a lot of time. At that moment, what will happen? The execution will go with the normal flow, the execution will keep on going. But this particular problem was taken care by Spark, and then they have you can say they come with new feature, that is AQE. So inside the AQE, what is happening, it is Spark is going to work onto the dynamic stats. Previously without AQE, what was happening, the execution was based upon the initial plan which is given, and if there are certain changes, no variation inside, there will be no any variation inside the plan. The execution will happen according to the initial plan. But after AQE, the dynamic stats are being captured by Spark, and based upon the dynamic stats, uh, it is going to check the available resources, data size, and then it is going to prepare a new optimized plan. So it is not like say Spark is moving with the initial plan or static plan. It is working on to based upon the dynamic plan, and which is prepared based upon capturing the stats of resources which are available inside the system at a particular instance. Okay, at a particular instant, the availability of the resources will lead to uh, change in plan, and then the job execution will be there with low latency. You can think in this particular way. Initially, once the plan was prepared, the static plan was prepared, say the 100 applications were running inside the cluster, but this was the big application, and now all the 99 application has been executed and only single application is there, but it is executing with the normal flow, with the availability of resources, with the now I'm having a lot of resources inside the cluster, but uh, the application is executed with the initial executors or resources. So with the help of AQE, it is going to check the resources, and it can increase or decrease the number of resources that is given to a particular application. That is the benefit of AQE. AQE, let me write it over here. It will be having it will be having dynamic stats during the job execution, like available resources, data size, and prepare optimized plan. Okay, so that is the benefit of AQE. Another stuff what will happen with the help of AQE, that is adaptive skewness handling. Adaptive skewness handling. So can anyone tell me what is skewness? What is skewness in what is the meaning of skewness? What is skewness, friends? Shivam, Rahul, Vandana, Naresh, what is skewness? What do you understand by skewness?
Some trend in graph.
A trend, that is fine. Let me show. Say I'm having this is also a trend. Is it fine? Can we call it as skewness?
No, like if it is going up or down.
Up and down. That's fine. So up and down. Okay. So skewness in the big data world, basically what is happening, uh, the unequal distribution of data, right? The unequal distribution of data. In the PySpark world, basically we are having different partitions, and the partitions are carrying the data, and the execution will happen. These particular partitions will be given to executors, and then the execution will happen based upon the partitions. Okay, now you can think in this particular way. we are having 10 executor and we are having 10 TB data. Now, what has happened? What has happened? These 10 executors, and we are having 10 partitions as well. 10 partition, 10 TB data, and 10 partition, 10 executor. But the issue exists over here. The 9 TB data is given to one partition, and rest 1 TB data is given to remaining 9 partition. Right now, 9 partition almost 110 GB. 110 GB. Okay, so almost 110 GB data will be given to, say, each executor, each 9 executor. 1 TB divided by 9, you can think that will be approximately, say, 110 cross 9. Okay, that is around, say, 1 TB. Now, just try to think in this particular way. One executor is working on 1 TB data, and rest 9 executors are working only on 1 TB data. One is working on 9 TB and 9 executors are working on 1 TB data. So unequal distribution of data is there, and that is nothing but skewness. So adaptive skewness handling, that is a property, that is a feature of AQE. What will happen? It is going to apply a coalesce or repartition. It is going to apply coalesce or repartition. If like we are moving with this particular flow, say if we are giving 9 TB data to one executor and rest 1 TB data to remaining 9 executor, definitely we will get out of memory related challenges. Okay, now in order to tackle this particular problem inside the AQE, what we are having coalesce. It is going to check the data, the size of data in each partition, and it apply coalesce or repartition by itself. Repartition. So repartition, say if we are going to we are having 10 dB data, and if we can apply the repartitioning onto top of this, so what we can say, repartition 200. 200. Now this 10 TB data will be divided into 200 partition, then 200 partitions will be given to these executor. So probably 10 partitions will be there on each and every executor. One partition will go, that will be executed, then the second partition will come, and then that will be executed. Or it might be possible like we are having multiple tasks based on the core, what we are having. You can think in this particular way. If we are having 10 executors, 10 executors are having 5 core each, and then 50 tasks will be executed in parallel in that particular cluster. Are you able to get? Just have a look onto this. 10 executor, 5 core, 50 tasks in parallel. Okay, so if we are having 200 executor, 200 partition, then 50 tasks will be executed, then rest remaining 50, then like next batch of 50, and then the final allot of 50 partitions will be executed, and then the outcome will be clubbed together, and will be able to get the outcome. So what we are able to see inside the AQE, adaptive skewness handling is a characteristic that is given by this AQE, and out of memory related challenges has been taken care. Skewness is what? Once we are having unequal distribution of data among partitions, right? So adaptive skewness handling is a property or a feature of or a benefit which we can get from the AQE. Are you able to get Vandana, Naresh,
Yes, sir.
Rahul, Shivam, all of you?
Yes, sir.
Rahul, is it fine with you?
Yes.
Okay, perfect. So AQE, first, first we have gone through what is AQE. So it is working onto the dynamic stats based upon the current resources and data size. It is going to prepare optimized plan, and then the execution will be happening accordingly. And if we are talking about the benefits, so from the AQE, we are getting the benefit of adaptive skewness handling. Skewness is a bottleneck inside the PySpark or big data world. So skewness shouldn't be there. It must not be there. So if skewness is there, how to tackle this? So we can enable this particular property, and then it will take care of this particular uh, stuff. If skewness is there, it is going to apply repartition or coalesce by itself, and the things will be taken care in a good way. Another benefit what is given by AQE, that is predicate push down. These are certain fancy word. Predicate push down. Fancy word, and if you are using these particular words during the interview, then it will be more effective, and the interviewer will be impressed. So predicate push down. Predicate predicate push down. So what is happening? What is the meaning of predicate push down? Now you just think in this particular way. Uh, we are having a data of 1 TB. We are having the data of 1 TB, and we are performing certain operations onto top of this particular data, and the entire data is not required. It might be possible the entire data is not required. So what is happening inside the predicate push down? It is going to apply filter mechanism, so unwanted data will not be moved. Let me write it down. It will apply filter like mechanism so that unnecessary or unwanted data will not be moved. Okay, so it is going to avoid the movement of unwanted data. We know if like shuffling is there, if the shuffling of records is there among the different executors or among the different nodes, then that is the costly operations. If the records are moving among different machines, we call it a shuffling. If shuffling is there, then the latency will be high, and if more data is shuffled towards the node, then definitely it is going to add more latency. So over here, with respect to the predicate push down, the Spark is going to check, the AQE property is going to check the unwanted data. If certain data is unwanted, then it is going to avoid the movement of that particular data, and by this means it is going to do the optimization onto top of our queries, and the latency will be minimized. So predicate push down is another feature of, or another benefit of AQE. Then next benefit what we are having, shuffle file consolidation. Shuffle file consolidation. So what is the meaning of shuffle file consolidation? This property AQ is going to check the files. If the files are having less size, or the partitions are having less size, then what it is going to do, it is going to club those particular files and make a bigger one. Because Spark or the big data, inside the big data domain, if we are having small size of file, then the performance will not be good. So in order to boost the performance, what it is going to do, it is going to consolidate the small files or small partitions together so that we will have the bigger one, and then the optimization will happen in a good way. And I'm not talking say you are going to have the partition of 10 TB size. It is not like, say if the partitions are of 1 KB, 2 KB, 30 KB. So what is the meaning of those particular partition? If we are giving it to an executor, then definitely it will be that particular job will be having more latency. So what we are going to do over here, we are this particular property, the Spark is going to consolidate the smaller files together and convert it into the bigger one, so that the operation will happen with low latency. So that is another benefit which is given by AQE. Now you might be wondering, these are the benefits, and we need to do a lot of things in order to have this particular stuff. That is not true. So it's very simple. What you just need to do, you just need to enable a particular property, spark.sql dot adaptive dot enabled, enabled enabled, and then you just need to set it to true, and that's it. You have set this particular property, and it will be enabled, and the Spark will take care of these particular things. This particular property will take care of these particular things. Just have a look onto the PyCharm. Let me open the PyCharm. How we can write it, how we can enable this particular property. Okay, so it's taking time. Python file, and what we can have, week 19 and day, that is what, day 29. Distributed processing with PySpark. So what I was saying, it's just very simple. Let me try to copy all of this particular stuff, copy and paste it over here. Okay, and these particular property where we are going to set in during the spark session. Once we are defining the spark session, once we are creating the spark session, then we can define these particular properties. So over here what we are having spark dot session dot builder, and let me try to mention app name, and then after app name what we can have dot config, and inside the config what I can do, I can set this particular property, spark dot sql dot adaptive dot enabled, and adaptive query will be enabled, and that's it. That's it. Okay, so this particular property will be enabled, and now it will take care about this partition, college, okay, predicate push down, or um, consolidation of smaller files. So these particular things will be taken care by this particular property, and we will be able to do the execution with low latency. That's it. This is the property what we just need to set, and then it is going to work in our code, and we will be able to get the outcome with low latency. So this is the property. Now moving further, we are having another property, another feature basically, that is speculative execution. Again, fancy word, speculative execution. Speculative execution. Let me show you certain diagrams. Speculative execution. I just want to have certain images. Okay, so we can go with this particular image. That is perfect. Hmm. So over here in this particular diagram, what we are able to see, okay, in this particular diagram of speculative execution, we are having node X, node Y, and node Z. Three node cluster is there, and node 1 is having a particular task, and that is slow in nature. So that is slow in nature, and we don't have any visibility when this particular task will be executed. This will be you can say deadlock like situation. We are not able to get the outcome, and it is going to occupy the resources, and we are not having the information like when it will be executed. uh, One more thing over here, once we are going to have the speculative execution, then there will not be any crunch of resources inside the cluster. If the resource crunch is there, then speculative execution is not a good property. So what is happening over here, if a particular task is slow and that is creating that is like being executed, and we are not having the visibility and creating a deadlock like situation, so what we are going to do, the scheduler is going to check or monitor, and based upon this, what it will do, it is going to launch the same task onto the different node. Just have a look over here. The node X was having a task, okay, and that is slow in nature. It has been monitored. Then on node B, okay, the task, duplicate task, same task has been you can say started. Now the output, say if we are getting the output from B, if like we got the output from B, then we are going to cancel the A task, the task which is executed at node A, and if the A task has been executed, then we are going to cancel the the task which is executed from the B node. So you can think in this particular way. Let me show you. Say over here as well, probably you are able to get from the diagram node A and node B. Node B. So it is having a task that is slow, that is slow in nature. That is slow in nature. Node A, and it is executing this particular task. Now we are going to enable the property of speculative execution. So inside the speculative execution, what will happen? This particular task, the same task will be started onto the node B, and now both of these particular machines, node A and node B, will be working onto the same task. The issue over here, we are going to occupy more resources. We are having more resources. Say node is A is performing the same task, and node B is also performing the same task. So that is a challenge, or that is an issue basically, because both of these two, you can say, nodes are working onto the same task. So over here, duplicate task, duplicate task is started, and if the A is able to execute the task first, then sorry, B is execute the task first, then A job is dropped, and if A is able to execute the task first, then B job is dropped down. So the scheduler is going to monitor all of these particular things. The resource manager is going to, or the driver is going to monitor these particular things, and which one is executed first, that will be taken, and the another one will be dropped. So that is nothing but speculative execution. So this particular approach is providing certain benefits. Benefits benefits of speculative execution. Benefits of speculative execution. So what we got over here: improved fault tolerance, uh, by mitigating the straggler straggler task. Again fancy word. Straggler task which are stuck down. So by it is going to improve the fault tolerance by mitigating the straggler tasks. Straggler tasks which are stuck or creating the deadlock like situation. So with the help of this particular speculative execution, duplicate task is executed started, and if the node which is having the duplicate task is able to do the execution first, we will be able to get the outcome. So fault tolerance is there. It is not like say this particular job will fail and then we will start from the beginning. It will not the case. Okay, which one is going to do the execution first, that will be that output will be taken, and the another one will be dropped down. So by this means it is going to improve the fault tolerance, and how? By mitigating the straggler task. Then another one, faster job completion. Faster job completion. Faster job completion. So multiple tasks, multiple nodes, multiple instance will can work on straggler task. Okay, so what is the meaning of this? Multiple instance can work. Basically what is happening, say node A was having uh, two executor, or we have given two core and say 16 GB RAM, but we came to know that it is taking too much time. So what we can do, we can initiate another task with higher resources, so that the execution will be done in a faster way. And uh, we are not able to get the information like how the task has been struck down, how the task became the straggler task. So uh, so over here we can increase the resources as well once we are going to start a duplicate task. And by this means, what we get, the faster job execution completion. So the duplicate the machine, the nodes or the instances which are having that duplicate task, they will be able to do the execution in a faster way. So that is the another benefit of speculative execution. Then resource utilization, improve resource utilization. Improve resource utilization. So the straggler task was creating a deadlock-like situation. It is not accepting the further task, and it is not executing the ongoing task as well. So those particular resources uh, are waste, because we are not having the information by when this particular job will be completed. So because that is the straggler task, a straggler that has been stuck, that has created a deadlock-like situation. So once we are going to drop that particular task, and then we will be getting the improved resource utilization, we will be having those particular resources. Uh, it is also correct, like if we are giving the duplicate instance, if we are starting the duplicate task onto the cluster, then we are going to occupy more resources, and occupying more resources, that means uh, decreasing the utilization. But for that particular job, that is fine. But what about the rest of the jobs? Say that the cluster is keep on executing, it is keep on working, and it can take 100 jobs, but because of the struggler task, only single job is being executed onto the cluster. In that way, we can say the utilization has been degraded once we are having straggler task. So by the speculative execution, we can drop the straggler task and then boost or improve the utilization. So these are the certain benefits, but we are having certain issues as well with speculative execution, disadvantages with speculative execution. So over here you will be having the idea, or say increased resource computation, consumption, increased resource consumption, increased resource consumption. What it means, two nodes are working onto the same task. That is clear. It is going to increase the resource consumption. Then redundant processing. Both of these are, you can say, linked to each other. Increased resource computation, redundant processing. What it means, two nodes are having single task. So we are having duplicacy here. So redundancy is is more over here, redundant processing. Then the third issue, what we can have, uh, network and storage overload. Network and storage overload. Definitely. So two tasks are working, two machines are working onto the same task, then definitely network and storage overload will be there. And then then the last one, and you might uh, think unpredictable performance impact. Okay, unpredictable performance impact. Uh, Basically, we are having speculative execution, and we are assuming that task A, node A, that is having slow task, and it has triggered the deadlock like situation. And by using the speculative execution, the same task, the duplicate task, will be started onto the node B, and it will be executed. But we can't predict, that it will be executed. We can have again deadlock like situation for node B as well. So that is the meaning of this particular line, unpredictable performance impact. We can't predict. We are assuming that with increasing amount of resources, uh, we will be able to resolve the deadlock like situation, and we will be able to get the outcome. Yes, it is providing certain benefits, but it is having certain disadvantages as well. Okay, so speculative execution is a property that you need to configure after having discussion with your solution architect or your manager, whatever. So you just need to first discuss with your architect and then enable this particular property. Speculative execution is having these particular disadvantages as well, which we have covered over here. So that is nothing but speculative execution. That is the functionality of speculative execution. And now the main thing, how we can have speculative execution. So that's very simple. You just need to set a property, and the property name is spark dot speculation enabled. Spark dot speculation, SPECU, speculation dot enabled, and then we just need to set it to true. Okay, and the interviewer can ask like, can you suggest a configuration which can boost the performance and which can have the negative impact as well. You can say we can have a property or configuration that is speculative execution. It can increase the performance, and it can decrease the performance as well. It is having certain other we can say issues. So spark dot speculation enabled, and that's it. Perfect. Spark dot speculation dot enable. What is the issue? Okay. Spark dot speculation dot enable, and we just need to set it to true, and it will be enabled, and we will be able to get these particular benefits. But you just need to uh, think about the disadvantages of speculative execution. It can lead to have unpredictable performance, network and storage overload, redundant processing, or increase the resource consumption as well. Just have a look and ask if you are having any doubt on to the speculative execution. Ask if you are having any doubt, friends.
Uh,
Naresh. Yes, yes, yes.
yeah, sir. When we increase the resources, it's increase our cost also. Then why we increase the our resources?
That is fine. If we are, you can say, triggering the duplicate task, that can lead to increase the resource consumption. But over here, either you can tolerate or you can bear to drop this particular task and do the execution. We don't know when it will be executed. It is having deadlock like situation. It is the straggler task, right?
Sir, right, sir. But in disadvantage, we so that increase the resource consumption. That is the disadvantage, you know.
Resource consumption, friend,
Yes, yes.
like why we are using resources, why we are having resources in order to do the execution of something. If we are not able to do the execution, if we are not able to get the outcome, then what is the benefit of execution? Why we are taking resources? So definitely we need to process something, and process involves certain cost, right?
Yes, sir.
Process involves certain cost, but if certain resources are are occupied for longer duration, then also we are having huge cost.
Okay, okay.
Okay, so if certain applications are straggler in nature, those are created the deadlock like situations which are occupying resources. Either we can bear to drop those particular tasks and do the execution again, or start a duplicate task with the increased amount of resources. Then then uh, whichever whatever uh, resource or node is going to provide you the outcome, take that particular outcome and drop the another one.
So that is also unproductive, no? That is also unproductive.
Yes, you just need to I gone through with these particular disadvantages, no? So
Yes, yes, yes.
it can impact, it can boost the performance, it can boost the performance, it can improve the resource utilization, but but we are not sure until unless we are not doing, we are not sure. These are the, this is the only property or configuration which is providing, which is having certain issues,
Okay,
okay.
sir. Okay,
So
okay.
so if you are having resource crunch, then definitely go with dropping that particular application and do the execution again, it is not
Yes,
like
sir.
say you are providing more resources or running the duplicate task, and those particular two nodes will be occupying the those particular two tasks will be occupying the resources. Okay, so drop one and do the execution of single one onto the cluster, right?
Right, sir. Right, right.
So that's why I mentioned you need to have discussion with your architect, and move uh, based upon his recommendation, okay. You can propose this particular property,
Right, sir. Right.
okay.
Good.
So that is speculative execution, now the another property what we are going to discuss, that is dynamic partition pruning, DPP, again fancy word, dynamic partition pruning, DPP. Okay, so dynamic partition pruning, this is a property, and it also came in Spark 3.0 feature and introduced in Spark 3.0, and the main, let me write it in this way. This is a feature which was introduced in Spark 3.0 to optimize query performance by eliminating the unnecessary partition during the query execution. Okay. So with the help of this particular line, you are able to get the information. Pruning means eliminating or removing. So what is happening inside the big data world or PySpark world? Once we are going to do the processing of our data, we will be having multiple partitions. Data is there in terms of partitions, and for the processing perspective of our data, if we are not requiring certain partitions for the processing perspective, this particular feature is going to check those particular partitions, and it will eliminate those particular partitions and move with the remaining partition. That is the functionality of feature. Move with the required one. There is no need to have ambiguous partitions for the processing perspective. Just eliminate which is not required. That is the feature. That is the saying from the feature: eliminate which is not required. Okay, so it is going to eliminate the unnecessary partitions, and it is happening during the query execution. So it dynamically prunes partition based upon actual data statistics. So, and what will happen? Reduced the amount of data processed and improve query execution time. Definitely, if like we are having less data in order to process, that will be processed with less latency, and the query execution time will be minimized. That will be minimized, that will be decreased. So we will be getting the low latency. So all of the features what we are having, what we are covering, these are based upon the application level optimization, and these are required, or we can enable these particular properties or feature in order to boost the performance. So how we can have this particular feature? Just have a look. Dynamic partition pruning. So what we can do, spark dot sql Spark.sql dot optimizer dot dynamic partition pruning enabled dot enabled enabled, and that's it. True. So dynamic partition pruning, this particular property is going to eliminate unwanted partitions, and by eliminating unwanted partition, the processing of the less data will be there for processing perspective, and if less data is processed, then definitely we will be having low latency. So this is the way in order to enable this particular property. And true, that's it. Okay, so spark.sql.optimizer.dynamic partition pruning dot enabled, and the that is set to true. So this is again a property which is utilized in order to boost the performance of our queries. So dynamic partition pruning. Just have a look and ask if you are having any doubt on to top of this. Just have a look. Naresh, Vandana, Rahul.
No, sir, no.
Sir, can you move back to predicate push down? How to implement that?
Spark.sql.optimizer.dynamic partition pruning.enabled, and that is set to true.
Okay.
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 Okay, so these are the three properties which I want to cover for today's session. Just try to go through, prepare your own notes. Basically, what will be the question that you will face in during the interview? What are the different optimization techniques that you have utilized in PySpark? So you just say AQE I have enabled. Then how you have enabled the AQE? What is the benefit of AQE? How AQE is working? I'm having Spark 2.0. Is AQ is there in Spark 2.0? Okay, so certain questions will be there from the interview perspective, and you need to listen the interviewer carefully and then answer. So try to prepare your own notes, and those particular notes will be utilized once you are planning for the interviews. So that's it for the today's session. Tomorrow we will cover rest of the optimization techniques.
Sir, adaptive AQ is not coming 2.0 or 2.0, no?
No. It came after 3.0. In Spark
Okay,
3
sir, okay.
it was evolved.
Okay,
And
sir, okay.
you can take it in this way, like these are nothing but telecom features. Inside the telecom only we are having certain features. So
Yes, sir.
same stuff is there over here. Right.
Yes, sir,
So
right.
these are features in of Spark which are utilized in order to boost the performance. In order to get more performance, we are having multiple features. Probably in Spark 3.5 we are having certain more features. So that is recently released Spark 3.5. I will identify what is new in that particular version, and I will provide you the insight of that as well. So that's it, friends. Take care. Have a good day.
Okay, sir. Thank you,
Thank
sir.
you.